Okay, hi, this is Will, and here I've done a couple videos. This is the Factory I/O basic pick and place system, and we had done it with the control I/O, which is the functional block diagrams. If you don't have a PLC, we've done it with Allen Bradley's micrologics, just with ladder logics. If you do have that type of PC, and now we're going to do it with the Siemens. We're going to use the TIA portal, but we're going to use the an S7-1200 PLC. And this is pretty much the same thing that we have now. It's already got the exit chute sensor put in there. If we look at the view all sensors, dock all tags, I've already taken off the emitter off of forced on and the remover off of forced on, which are kind of defaults for the Factory I/O. And you can look at one of those two videos for exactly what, how the setup is. We're going to put an item on here. We're going to go to the item at entry. We're going to use the pick and place to go down, pick it up, move it over to the output conveyor, drop it down, let it go, go back to the home position, and we're going to control, the emitter is always going to be on. We're going to control the remover, and we're going to control the conveyors. But we want to concentrate on the Siemens. Now, the first thing is, if we look at, we had a tutorial for what Allen Bradley's micrologics is. And if we look in here, we also have setting up the Factory I/O. And they have that same simulation, the sorting by height. They have that sample program. So you can take a look at that if you have any problems. Now, in looking at this, and I guess somehow I knew this, but I wasn't thinking about it. They also have Plc Sim, and this is a simulator of a PLC for the S7 series. And I'm pretty sure you can get a 2-week trial of the software, and the software is really high-level software. It's different than the Allen Bradley micrologics. It's certainly different than the control I/O. It's got a lot more capabilities. But if you have Plc Sim, because it simulates a PLC, you don't necessarily need an actual PLC. Now, having said that, it is pretty involved using it. So before you get the trial version, which only lasts for 2 weeks, you should study up and figure out, how you're going to use this efficiently. But if we look at the setting up Factory I/O, if you looked at the one with the micrologics, all you had to do was basically the inputs were on memory bits, the B file, and that was the basic setup. And we'll go through some of these, creating a file and configuring a device. But the main thing that you have to do, and again, this is going to be Ethernet. That's industrial Ethernet, the IE. This is just the adapter that you have. And I have a USB to Ethernet adapter. But the two things that you need to do to set up the PLC to work with Factory I/O, one of them, and here's the Ethernet address, but one of the things is the start address. Normally by default it'll be 0. It has to be changed to 10. And we'll show you how you do that. It's in the general setup for these. In here, in this general setup, are all the configurations you can do to the hardware, and this happens to be one of them, the start address. The other thing is, usually by default you're on full access, but the one thing you need to make sure of, because Factory I/O is not part of the Siemens family, is that you click on this permit access with the git put. Otherwise your communication won't work, and you might have trouble figuring out why it won't. So that's about it. And then you need to download it as the hardware configuration that you've changed. So let's take a look at the TIA portal. And let's see, this is really what we want. This is create a new device, and I guess I'll just call it Project Factory I/O PNP, and I'll just call it S7-1200. And we just say create. Now this is going to take a little bit of time to create this thing. And I don't think I need this screen. But once it comes back, it'll create the project, and then I'll have it set up. And then we need to add the device that was shown in the tutorial there. And we can take a look at that. Now, depending on, we'll see how long this takes. This takes a little bit of time. If it seems like it's taken too much, I'm going to pause it for a second. Okay, that did take a few seconds, but when you come back, it says configure a device, and here's what you can do. You can configure a device, write the program, technology objects, or an HMI. What we want to do is just configure the PLC. So when it comes back, it will show the different type of devices that are available in this, and the software that I have is just for the basic PLCs available, and that is just the 1200 series. The 1500 series is the higher level one, and that software is much more expensive. And I do have, this is version 15.1, and it is totally integrated automation. And what that means is you can use the software for the PLC, for the HMI. If you have it from PC control, it works for all of that. And we want to add a new device. And this one also takes a bit of time, so I might just pause this if I'll give it a chance, but if it doesn't come back here, I'll pause it for a few seconds. And okay, here it is. So right now, these are controllers. You can have HMIs and PC systems. Now, again, I just have the software for the 1200. And my CPU happens to be, and you have to know, and you can read it right off the PLC, but mine is a 1214. It's AC DC relay, and what that means is that AC input, it's got DC inputs and relay type outputs, and that's my model number. And when you pick it, it's going to tell you what you got. You know, it says 120 power supply input. It's got 14 sync source, which is DC inputs, and then 10 outputs, which are relay types. You know, it'll tell you it's got 6 high-speed counters, and you know, tell you all the information you need to know to kind of gauge whether it's got enough horsepower for you. So we're going to add this, and then the screen will change, and it'll show the PLC, and it'll have it in a simulated rack, and then we'll program those parameters as far as the address and the get put. And I think I'm going to let this pause for a second. I'll be right back. Okay, now this shows the PLC. It's being in slot 1, and this is what they have device view. If you looked at network view, if you had another device, it would show you what it is, but this just shows, if you had a HMI, it would show a connection there, but this is okay for our device. What we need to do is, and let me pull the bottom up here, if we go in here and we click on our device configuration, and then we go into properties, and again, this will show us all these properties that we can configure for what we might need for this. Now, what we're going to do is we're going to go up to the top, and this is where we have the I/O addresses. If we click on that, you can see the start address is normally 0, but we want to make that 10. That's one of the 2 changes that we have to make, and we're okay with that. Now we need to go down to this protection and security. And when you go into the protection and security, normally you're at full access, and that's not normally a problem. But what we need to do is the next one down here is the connection mechanisms. And you have to have the get put or put get communication. And pretty much you have to have that if it's a non-Siemens type device, because the factory I/O is going to get the memory address from the PLC, and it's going to put some, you know, whether a coil is on or not, into the memory. So you have to check those 2. And then what you have to do is load those. These are hardware configurations. So if you click on the PLC, left click, and then right click on it, it'll give you this pull down, and you need to download to device the hardware configuration. And I guess before that I do that, I'm going to go up here, and this will, the PLC and the software will look for what are the accessible devices connected to it right now. And actually I have both the PLC and an HMI connected to it, so we should see both. Now we're not going to be using the HMI for this. And I'll give it a chance, but if it doesn't want to come back, we're going to pause it again. Okay, now this is saying, on what interface do we want? And we always want this PNIE interface. Now this is my little USB to Ethernet adapter. So that's kind of the adapter that we need. Now we're going to start the search, and it's going to go out and it should find the address for the PLC and the address for the HMI. Now the PLC is always by default going to be 192.168.0.1. The HMI will be 02, and you can see this. So you come back with the addresses and the MAC addresses. And that's all we want to know, is that, yeah, it can see those devices. So we can go back to what we originally started to do. And we can right-click on our PLC here. That didn't do what I wanted to. So I want to go to my PLC, click on that, and I want to download the hardware configuration. And that'll put the protection as well as the address information in there, and then we'll be ready to program it. And the programming is what we really want to take a look at, how we do this, because again, it's a little bit like coding for computers, and it's not that great of a big advantage. For if you're familiar with that, you'll love it. But and once again, when we load stuff, we need to start the search. And then this is shadowed out right now, but when it finds the device and everything, then we'll be able to load it, which we are right now. If you like this type of programming, it's not so helpful with this program, but if you get into more complicated programs, it's really helpful. And I think we'll do some little videos on more complicated factory I/O, along with doing them with this type of, the structured control language or structured text. And, your best, I think the best bet is to, combine it. Everything doesn't have to be, the really high level stuff is better off to be in the structured text. The lower level stuff can be in the, lower level. You can do it in, you can combine ladder logic with structured text. You can combine function block diagrams with it. So anyway, this is going to start the module. If we hit finish, we should do that. Now sometimes where it says start module, it'll be in pink. And if it's in pink, it usually has a pull down menu, and you need to do some selection if it's in pink. So if we go into program blocks, we'll go into our main block. And when you get into the main block, here's where you write your code. Now, based on what we're doing, we have this moving X signal, and we want to know when it goes from active to inactive, which is from a logic high to a logic low. And so what we're going to do is we're going to put in some falling edge triggers for those. And this is also a little different than Allen Bradley, because they have what they call a network. It's not a rung by rung, and you can put one. You can use them as rungs, so only one line of code is in one network, but I generally like to group them. So if I want to put my edge triggers, I'm going to put them all in the same network. So we have our moving X signal and our moving Z signal. And here, all I do here is I don't have to go to any file. I just type in my signal name. So I've got a moving X. Now, I also want to make it a one-shot. So we'll have to change this type of gate. If I click on here, there's this little orange triangle in the corner. If I click on that, I can pull it down. I can have normally open, normally closed. This is a rising edge. P is positive. This is the negative edge. So now I also need, this is a one-shot just like an Allen Bradley. So I'm going to give it a name of ONS1. And for my output that I'm going to use in the program, which is going to be a one-shot, so it'll only be true for one scan. And we only want it for one scan because we're counting pulses, and we only want to do it one time through the code. So I'm going to say this is going to be my move X. I think I want underscore X done. So now I've got my names. I've just put in names. You know, in Allen Bradley you put in the addresses and then you put in the names. This is the opposite. So if we look at our factory I/O, moving X, and if we go into the driver section, and this is again in the Allen Bradley micrologic, so let me just switch it over to the Siemens 1200. And just like we had to do with Allen Bradley, right now the emitter and remover aren't on the outputs, and we also don't have this exit chute on the inputs. So if we click on configuration, we can make the number of inputs 12, and we can make the number of outputs 12. And we can go backwards. And all we do is drag our signals to where we want them. So emitter is going to be there, our remover is going to be there. And the exit chute we're going to put in 1, 3. And that's all we need to do with the PLC. And again, if we look at the configuration, this will say it's a S1200. This is our host address. This is my network adapter. And that's what we need. So if we go back here, moving X is input 02 and moving Z is 03. So what I want to go is back into the TIA, and if I right click on this, I can go in and say define tag, and this will be a global input, and it always will assume the very first one available. Now we said that this was 02, and we'll define that. Now these other ones, the ONS and this, are going to be our internal memory bits, or what we call in here are the global memory. So we can just pick these as global memory, and it picks the first one available. For the inputs, we need what is actually defined in factory I/O. For the internal memory, you know, whatever factory I/O picks is good enough, and that's a really nice feature of it too. So we define that. Now I also want to have moving Z. So what you need to do for this is you can click on this rung and then say I want to add in another rung. Now what I can also do is one of the things that you have to do for this is you have to do Control C and then Control Z to copy. You can't drag it like you can, Control C, Control V. So here, what I can do is I can just change this from X to Z. I can change this to move Z. And I can change this to ONS2. Now when I do that, all the tags are now not defined. So this one is input 03, global input. And this one's a 3. These are both memory bits, so I'll just let the program pick them. And I'll do the same with this one. Now there's one more edge trigger that I want to do, and that will be for, I need to know this exit chute. I need to know when the item passes down and it's sliding down this little ramp or slide, and that's when I'm going to turn on the remover. So I want a pulse to tell me that. So again, I can just select this, select it, put in a little stub, and then I can copy one of these. And this one is, we call it exit chute. This one I'll call ONS3. And this guy, I'll call him, because I'm using him for the remover, I'm just going to go in and call him remover pulse. Because it is just going to be a pulse. Now this one is input 1.3, so it's global input. It's 1.3. These other ones are still going to be global memory. So define tag global memory, that's good enough. Do the same here, global memory, good enough. And there we go. Okay, so that's all we're going to do to make it look. And one of the things you can do in here is you can click on the network and say define the edge triggers. Now what I'm going to do here is where I'm going to start my SCL logic, and basically I'm going to add a new block, and we're going to add function blocks. The difference between this function block here and a function is a function block comes with memory or a data block. We're just going to have straight up logic, and what we'll do is we'll call it start logic. And you can see here it's language. This is SCL. You could either do this in ladder logic or functional block diagram. Now, when I said before you can combine them, not in the same function block. You can have one function block be ladder logic, the next function block be function block diagrams, and then another one be SCL, but I don't think you can actually combine them all in one function block. I may be wrong on that. But when you do, you get kind of a blank screen, and you have to write the code that you need. And I'm just going to start doing that for the first line, and then I'll come back and explain what we have. So normally I always have a signal called start process, and that means that the start button has been pressed. Now when you write this code, you have to do colon equals, and somehow I think I popped out of the wrong spot. Okay, so that equals our start push button, or our start process signal, can't type very well, and the stop push button. And so you have, when you're starting the assignment, you have a colon. At the end of your statement, you need a semicolon. Now, we have all these things underlined because we haven't defined any of these tags. The start process, we're going to define it, and that's going to be a global memory. And now here it shows up as an int, but it's not really an int, it's going to be a bool. And when you do that, it'll go in and give you the next available one. Now the start And you can see the start process here and here. Okay, now the start push button, and we have to go into the drivers again to figure out where they are. The start push button is 05 and the stop is 07. So it's input, global input, and again we need to change that to bool. And here 05 and the stop will be 07. Yep, global input. Okay, so that's defined there. And now all of these have no red underlines. That means they're good. If you want to know if you have the syntax correct and whatnot, you can always do this compile, and it'll tell you down on the bottom where everything compiles correctly. Now I'm going to take a break because this is taking a little bit of time. I'm going to put all the logic in for this start logic, and then we can come back and talk about it. So we'll be right back. And I guess before we do that, because it did compile, you can pull this up, and here's where your kind of messages are. But it says block was successfully compiled. So we'll be right back in a sec. Okay, so just to show you, this is start project process is assigned if it's the start push button is pressed, or if start process is already active and the stop push button. Now if we look at the Allen Bradley program, and I have it pulled up here, it's start process or start push button or start process, and the stop push button is what start process is. And the next line you can see, if start process is active, the emitter is active. If start process is active, the start lamp is active. So when we look at these next lines, it's the emitter is active if start process is active. The start lamp is on if start process is on. Stop if it is not. And I guess really I really want this to be not the emitter. I want this to be not start process. Even though the emitter and start process are the same, I think it makes more sense to say if it's not start process. And then the entry conveyor is when we have start process and we do not have anything at the entry. So that's going to be my block. I can, compile it, take a look at if it passes, and it says it was successfully compiled. So I'm done with that block. Now, that's all my start logic I'm going to want there. So when you get this, I can go to the next network, and here's where it shows up the start logic. All I'm going to do is drag that into here, and that's that. Now, the next thing I want to do for network 3, I'm going to add another block. And this is going to be my pick and place logic. And again, it's going to be SCL. And what we're going to do here, like those are all pretty straight logics, and if you can go online and you can find a reference sheet or on the web that'll talk about basics of SCL, and you can start working from there. But now here is where we're going to get a little more complicated. In SCL you can see that they have these statements like if then or for loops, while loops. What we're going to do for the pick and place is we're going to use an if then, and the way it comes up with the boilerplate is if this condition is true, then I want to do these things. So we're going to start out, and we start out with our move count. So it'll be if our move count equals 0, and anytime you type in a keyword, it'll come up as a keyword. and the item is at entry, then what do I want to do? Well, when it happens there, I want the move Z to be true. I want it to go down. Now we have a move Z done, but we don't really have the move Z. And when you want it to be active, you can just say, I want it to equal true. And that's a keyword also. So you can just say true, and that's what I want. And now the other thing is, while it's starting to move, I want to make sure I'm not grabbing it at this point. And so I also have a signal named grab, and I want that one to be false. And again, you just type it. And now for these two, I don't have those. I don't have my move count defined. I don't have my move Z or my grab signal defined. And actually, I don't need that last semicolon because I've got one there. So move count, this is going to be a memory again, but this one is going to be an integer. So when we say it's global memory, and we'll let it define it as integer, and that's good enough for us. Now the move Z is, if we go back here, move Z is Q03, and we want that defined, and grab is 04, so it's 03 and 04. So this is a global output, and it's bool, and it's 03. And this grab will be 04, global output. Now this next thing, what we're going to do, and we have to kind of do this setup for this first case to get our little machine rolling, and we'll talk about that as soon as we finish this first set of statements. So this will be 04, and we want to define that. Now, after our grab is false, what we want to do is we want to say, okay, if it's 0 and we're at entry, we want to be this condition. We want to be moving down, but we don't want to be grabbing. But now we want to say an additional if statement. And now we want to say if, and we can kind of just copy this. So we can say if I'm going to do Control C and then Control V. So we're still moving down, but now we also want to put in an additional and the item is detected. So now the sensor that's on the input says, oh yeah, I've already detected that item. So now we go down and its item is detected, and we go to factory IO, item detected is 14. So we'll define that as global input. And, oh. Invalid data type. Oh, okay, so I've got quotes at one end but not the other end. That's why it says it's invalid. So define tag, that's input 4. Okay, so now what we're still going down, we're at count 0, but now we've detected the item. So now what we want to do is we want to say our grab equals true, because that's at the point where we're going to grab the item. And we can kind of move him in a little bit. Oop. And true is active, false is not. Now, that's what we're going to do. Now, from here on, what we're going to do is we're going to do a case statement. And we're going to use case, the variable name, which will be move count. I didn't really want that to show up like it did. Not sure that that's right. So let me try this. Move. Okay, so move count. Now here, in case it's 1, what I want to do is I want to move, I've already grabbed the item here. Now I want to move back up. So all I have to do is I say in this case that move Z is going to be false. That's what gets it moving upwards. And semicolon, get rid of this. Now here I'm going to just get rid of those because I don't like that. Now if I go down here and I say, okay, if the move is 2, what I need is X, move X to be true. And I haven't defined my move X yet. And I think, okay, need my semicolon, and it automatically puts it on another line. But now I haven't defined move X, and I think my move X is Q02. So it's global output, and it'll be a bool, and Q02. Okay, so likewise, if I return here and I say for my step 3, now I want move Z to be 2, because now I've moved over to the output, I want to go back down. So let's see, I'll just copy this guy over. And for the 4th step, now what I'm going to do is 2 things. I want to go back up, but I want to let go of the part. So the first thing I want to do is I want to make grab, and I'm going to change grab from being true to false. So I'll change that to false because I want it to let go of the part. And then I want my move Z to be false again. So I'm going to copy this guy. And I've got a little too much copying here. Oh, I don't need that one. That would give me a syntax error if I had 2 semicolons. So grab is false, and move Z will be false. And again, I need to get rid of that last semicolon. So now on 5, we want move X to be false. And finally, the last move is move 6. And right here, move 5 moves X back to the home position. But my last thing right here is what I'm going to need to do is reset move count to 0. So move count equals 0. And that was not a semicolon. Oh, okay, I still need the colon because I'm assigning it. And I've got too many semicolons here. Okay, so that's all our move operations that we need. And at the end case is how you end it. Just like you have end if for an if statement, you have end case for a case statement. Now the only other thing we need here is we need to set up something that is going to count our pulses. So for down here, we're going to put if move x done, or move z done. Then what we want to do is we want to say then we want move count to equal move count plus 1. So that every time we get that negative edge, we're going to count. And these are all statements that we have, and this will control the pick and place, and that's all we have to do. So if we go in here and we say, well, let's compile this. Oop, now this gives us an error, so let's take a look. Incomplete instruction. And these arrows will let you go to it. So it says if, and what I have is I have a if nested within an if, so I need two end ifs here. So that's why that's no good. So I need an end if, and then have to have the semicolon. So now if we recompile it, and that's a really good feature. If it's an error in there, you usually can go in there and if it has a green arrow, it'll take you to where the problem is. So let's see. And I bet I don't have an end if here either. So again, we need the end if, and I'm not too good with the syntax, obviously. But that's a neat feature, is if you have a syntax error and if it has a green arrow, you can go exactly to where your problem is, and that helps you out quite a bit, especially if you have a longer program. So we still have one. I'm missing a then. Okay, so here's my then. That's not there. And now if I do the syntax, we should be good. And just like we did before, if we go back into the main block, we're just going to drop the pick and place logic onto a rung. Now, I need one more block that I'm going to put in, and this is going to be I'm going to call it the exit logic. And this is what's going to be for our remover circuit and our exit conveyor. And I'm just going to, I guess, kind of like the first entry logic, I'll write the logic and then kind of walk through it, since this is getting quite long. But we're going to do the same thing. It'll be a CL, and we're going to drop it into network 4. And with those 4 rungs, that should be able to control our program altogether. So I'll be right back with that final information. Okay, so just to finish up on the logic, there's a couple things. So I have this one that says when I'm going to start my exit conveyor, and it's when the item is at the exit sensor and I am not grabbing the device, so I'm letting it go. So when that happens, the conveyor will turn on, and then it'll turn off when I get the remover pulse. And again, the remover pulse, if we look at this, is when it falls over the edge and it's going down the slide. So that's when I turn the conveyor off, and that's what that logic is. Now the other thing in here is a little timer for turning on the remover. One of the nice little features in the Siemens is, you know, they've got the regular T on, T off, and you know, the retention T on timer, but they also have this pulse timer, and that will send out a pulse no matter, you don't have to enable it like you do a T on pulse. I can give this, and the remover pulse is one scan pulse. I can give it a scan pulse or, you know, 1,000 scan pulse. It is always going to send out this pulse, which is going to be 1,000 milliseconds or 1 second. It doesn't matter, you know, this enable or the input does not have to be on for that full 1 second like it would have to be for a T-on signal. So that's pretty good. And for the counter, I'm using the same remover pulse because I only want it, no matter how many times it goes through the program, I only want to count it one time and for each device. And, you know, I put an insanely high number in here because, you know, we don't really care about that. Now, the other thing, just for clarity, is in these new blocks, I also put in this startup, and this is like the first time through block. And actually I did this in ladder, but what that block looks like is, because the Siemens PLCs, if you turn them off to reprogram, they're going to hold the output at what it was. So every time I turn on this, I'm going to reset the outputs, and these are all the outputs, so they reset to inactive state, but then I reactivate the stop lamp, so the stop lamp is always on. And then I also move 0 into the item processed. And the item process, we can also reset that with the reset push button. So that's kind of what we got. Now if I'm going to load this into my PLC, so I'm going to, well, first we can compile it, make sure everything's okay. And right now, because we're on the PLC, it's going to compile the whole program. And there's, you know, input or outputs do not exist in the configuration. That's fine. And that's probably something that I didn't just clean up. And we go through the same loading process as before. And this just means that there is a different program in there than what we're trying to load. And so we can continue without synchronization. Now here's what I was talking about before. When it gives you something and it's highlighted in pink, you have to do something. And this will be, I'm going to have to stop the PLC because you don't want to, well, for what we're doing, it doesn't really matter, but you don't want to try to load in a completely different program without stopping the PLC first. And when it gets done loading, then I'll say, you know, restart the PLC. And after we restart it, then we can finish it. So it says start module. Like here it's not pink, so it will start the module just if I hit finish. And we want to go online. And I can pull this down. And when everything, before we had those orange and blue circles, if they're all green, that means things are good. If if you get one that says that it's orange and blue, what that means is what you have on your screen, what you're trying to program with, is not the same that's inside the PLC. So if we just go to our main block, and we can monitor the on-off, and then we can go into the factory I/O. Now here, I'm going to get rid of this, clear the dock tags, and now I need to connect up to the PLC. And we're okay if we connect up to the PLC, and the only thing that should be on is our start lamp, or start light. Okay, so that one's on, everything else is off, which means that we're okay with, we're in the correct startup position. Now our stop lamp is off, and as soon as we hit this will turn off, the start lamp will turn on, and then we should start seeing our emitters deposit stuff on the conveyor. And hopefully this will work, and you can see the signals here. Now again, what happens is this box is going to wait until it gets back to the home position, and then it keeps going again. And when this guy falls over the edge, you can see the remover turn on. And if we zoom in here, when the box falls over the edge, you can see the conveyor, which you can see moving right now. When it falls over the edge, that conveyor stops. So it's just a continuous flow here. And you know, if you study it, again, this isn't the best example because it's not really complicated, but you know, as far as some of the logic, and if we go and pick and place, and you know, people don't like it because it's not visual, so they can't see what's on and what's off. But actually, if you click on any of these logic blocks, and it'll let you open up the logic, and you can also monitor. Now again, what we have to do is we have to turn on the monitoring here, but it will tell you at any point, if you go into these, you know, what the count is, whether these statements are true or false. You know, it's a little more difficult than just looking at ladder logic, but here you can see the result is true, and you can kind of you know, try to troubleshoot your program that way. Now I hear, you know, I have the basic software for 1200, but if you have the other versions of PLCs and a higher level of software, you can do a lot of debugging in this V15 software that they have for the TIA. And you know, you can look down here and you can see the count when it goes back to 0. You know, you can see what's turning on true, when it's false, when it goes true, false, false, false. And so you can kind of understand, like, when move Z goes true, it's moving down. When it goes false, it's moving up or not moving at all. And yeah, it's a little harder, but if you have complicated stuff and you have to make a lot of movements, and if you can develop cases like, well, when my count is whatever, I need to go, you know, 15 steps left. When my count is, you know, 7, I need to go 20 steps straight ahead. It works out pretty well. So anyway, that's the show with the Siemens S7. And again, the way the tags are set up and the way the software is, you know, there is no difference between this PLC and a Micrologix for the most part. It's a software that's a lot more powerful. And this is the type of software that you get in Logix 5000 or Studio 5000 by Alan Bradley. It's just that that software is incredibly expensive. But, you know, if you want to try it out, you can get that. I'm pretty sure you can still get a 2-week trial version. Just make sure that once you get it, you're, you know, ready to run with it. So anyway, take care, stay safe.